The injection method of thermoplastic dentures has been around in dentistry for over 50 years, but some technicians still struggle with it. There are different situations, but a few problems always repeat. I will try to discuss them all. Before recording, I checked the statistics, and the opening of the cartridge is the most common problem I encounter in my practice. The command to lower the temperature always eliminates this problem. When it happened that the prosthesis injection failed, hardly anyone wonders why it happened, whether the prosthesis is properly modeled, whether the channels have the right shape and cross-section. There is a reflex reaction. Injection failed. Conclusion: the material did not melt. Action to raise the temperature. After raising the temperature several times, because the injection failed again, we reach the boiling point, the material starts to boil, and the cartridge breaks. You put in a new cartridge, the same, the next the same, then, most often nervous, you just start looking for the cause. Meanwhile, there is a simple method that allows you to clearly assess whether the failed injection was the result of failure to melt. It is enough to cut open the cartridge and see the structure of the molten material. If you can see clear plastic granules separated by gaps, the material is unmelted. If the surface of the material in the cartridge is smooth, the melting process was right. The cause of the failure must be looked for elsewhere. Try not to overheat the material, because the defects of the overheated denture are very serious, that is, the bursting of the cartridge and the outflow of the material. This is the smallest problem because we do not have to repeat the whole work. We lower the temperature by 5 degrees and try again. Pores in the denture, unfortunately denture to be repeated. Color change can be accepted, but this defect is related to another problem, which it is weakness in strength. The denture may crack. Boiled material loses its cross-linking and becomes brittle. A problem for all technicians, doctors and patients. If you find that the injection failure is evidently due to incorrectly set melting parameters, try to extend the time first and treat raising the temperature as a last necessity. But if the material is molten and the injection failed, what could be the cause? I was able to identify as many as 10 cyclical errors made by technicians. Let's take a look at them. Start looking for the reasons of failure with the simplest things. That is, check that you have connected the pressure. It may happen that you did not check the pressure at the time of injection. When you turned on the compressor, the pressure was okay, but it could happen that it came off the compressor due to some leakage. Remember that the disadvantage of compressors is unstable pressure. If you set a value of, for example, 8 bar on the compressor, there is no guarantee that it will be so during injection, because the pressure drops and the compressor turns on only, for example, at 6 bar, so you are never sure what the pressure is at exactly the moment of injection. Compressor on-off values can be set, but there is always some pressure drop. There may also be a situation where your colleague used compressed air for sandblasting, and at the time of injection the pressure on the injection machine was much lower. On the other hand, when you use a cylinder, you often forget to unscrew it. After the injection is finished, you turn off the cylinder. When re-injecting, the gauge shows the correct level because the pressure remains in the lines. But at the time of injection there is too little pressure to fill the actuator. Always check the pressure exactly at the time of injection. With a large denture, it may happen that the cartridge runs out of material. Look at the cartridge. If it is heavily crushed, there is no plastic in it. Cut open the cartridge. If there is no material inside the shell, the denture was too large and there was not enough material to fill it. Try to model a thinner denture plate. Cut the model and place the denture as close to the Flask channel as possible to keep the channel length to a minimum. The plastic in the ducts is a waste of valuable material. The main cause of injection failures are improperly modeled channels. So let's discuss what to look for when designing an inflow system. Excessively thin channels. This is one of the most common errors. The channel should have a uniform cross-section along its entire length. For the flowing material, the channel is an ordinary pipe. If you reduce it, you will also reduce the flow of material to the plate. The channel has as much bandwidth as its thinnest point. Most often, you cut the channel where it sticks to the plate. If the injection was not successful, cut the denture with the channel and measure its diameter. It should be uniform along the entire length of the channel. The narrowing of the channel may also occur as a result of improper installation of the model in the flask. If you mount the model too high or too low, the lumen of the channel may decrease due to a kink at the edge of the box. The edge of the can model should be flush with the bottom edge of the inflow opening. The channels must be oriented in the direction of the flow of the material and fixed at the beginning of the plate to facilitate filling the mold. Therefore, do not model them at right angles or too deeply. I strongly recommend using one channel. In the case of full dentures, an additional auxiliary channel can be added. Of course, it should also be modeled in the flow line of the material. The denture model should be as close as possible to the inflow opening. Too much distance increases the loss of material in the channels, and by increasing the flow path of the material to the prosthesis, it increases the risk of failed injection. If you are using two channels, make sure that they have the appropriate thickness. We have to use math in the formula for the area. If the main channel has a diameter of about 10 millimeters, the sum of the channel cross-sections should not be smaller. As a rule, you use channels with a maximum diameter of 5 millimeters. As the calculations show, it is even 50% too little. By using thin channels, you increase the risk of failed injection at the beginning. To ensure optimal transport of plastic from the cartridge to the prosthesis, the channel should have a diameter of up to 7 millimeters. Nobody uses such because as there would be no material left for a prosthesis. So maybe it's worth giving 3 thinner channels? Well, apart from the issue of plastic losses, remember the next rights of nature, that is, fluid physics. Similarly to the previously discussed case of narrowing, remember that the channel is a pipe. The melted material has no water consistency, but it is thick as tar and therefore has difficulty squeezing through thin channels. Even if there are more of them, 3 or even 4 small diameter channels have a lower bandwidth for a thick mass of plastic than one thicker. For this reason, the technique of modeling one channel is definitely more effective. We strongly suggest using one channel with a thickness of about 8 to 10 millimeters. If you model it properly, you improve the flow of the material because its diameter increases by the thickness of the denture plate. A properly modeled channel should be as short as possible and have a U-shaped cross-section. A common mistake is to stick the channel without watering its undercuts. Then the channel does not fulfill its role because the material flows into the plate with too little area. If the failed injection is located in the buccal or labial part of the prosthesis, the possible cause of the defect may be too small space between the tooth in the prosthesis and the model. The space between the tooth and the model should allow the material to freely penetrate, that is, the minimum thickness of the denture plate is about 1 to 1.5 millimeters. The more of this space, the better, but the thickness should not exceed 3.5 millimeters. Cut the denture open in the area of the insufficiency and check the thickness of the plate under the tooth. If it is too small, improve the tooth preparation. Pouring too much material is a common mistake made by people which are pouring the material on their own. They are afraid that there will be no material for a prosthesis and are pouring the granulate, filling the whole cartridge. The cartridge has a specific capacity and should not be filled under the cap. When pouring, leave the space for at least 2 centimeters. If you pour too much material, its part is outside the heating zone and the injection molding machine has no physical possibility of melting its top layer. If you are afraid of whether the material is enough for a prosthesis, do everything to reduce the channels and shape the denture plate so as not to process it anymore. This is definitely enough. If there isn't enough of material, it means that this is 1% when it is impossible to make a thermoplast prosthesis. In a situation where, despite the proper pressure and temperature, the cartridge will not open, it will get stuck in the sleeve or is not crushed, you should check if you put the cartridge with the right side in the injection molding machine. Such situations happen, and it is not so rare. I will remind you that their cartridge is to be put with inscriptions inside the heating sleeve. At the place of closing the cartridge there is a thinner side, which facilitates the opening of the cartridge. On the other side of the cartridge the wall is much thicker and the cartridge may not open. If you pour granules and add leftovers from mold injection, there is a serious risk that the granules will melt faster than a large part of the material. During the injection, an unmelted piece can block out outlet opening. It is not a good idea to use leftover denture residues. Firstly, cutting the remains from a 2-inch diameter cartridge and cleaning them is dangerous, tedious and time-consuming. And secondly, there is a risk of clogging the outflow of the material. I don't advise this.
Acron is a new polymer which is used in order to make perfect dentures. Test it and see why millions of patients in 30 countries love their Acron dentures. If you want to know more, visit ROKO.com.
Check if the working piston is not dirty with remnants of aluminum tubes. If there is a lot of dirt, the piston may get stuck in the sleeve. If you do not clean the piston, after several dozen injections, its surface may get dirty with residues from previous injections. Remove the piston, of course, when it is cold. Remove any remains with a knife and clean with a cloth. Do not process the surface of the piston with cutters. This element is precise. If you destroy its surface, will start to block more often. If the piston is used up, just replace it with a new one. The right lubricant has a great influence on the injection quality. It must ensure the cartridge will slide in the sleeve at a temperature of up to 400 C. It cannot leave carbon deposits and other residues. In order for the plastic cartridge to move properly in the sleeve, its surface must be perfectly smooth and slippery. If lubrication is poor, the cartridge seizes in the sleeve and injection may fail. Some have used petroleum jelly, oils and lubricants or other preparations that burn at high temperatures, leaving nogger, and instead of decreasing it increases friction. Only lubricants dedicated to dental injection molding machines, such as Lubris, should be used. Lubris is a special mixture of silicone oils with 3 different particle sizes, which ensure perfect glide and at the same time do not run off to the sleeve. Technicians often use various substitutes just because they are a bit cheaper. This is an apparent saving. All you need is one failed injection due to bad lubricant and your savings did not go as planned, and I do not count problems arising from repeated modeling and repeating of work. And do not overdo it with saving grease. To make his roll he must be the right amount. Too little amount will not produce a slippery layer, and the resistance of the cartridge in the sleeve can be too large. The probability that your injection molding machine underheating is minimal. The injection molding machine, like every machine, of course, requires control and calibration from time to time, but you should not overdo it, and even more so calibrate it on your own using amateur thermometers. Such measurements lead to the complete decalibration of the device and even greater problems. Calibration should be performed by a professional service. As we know, during the production of a traditional acrylic prosthesis, the polymerization process of polymethyl methacrylate takes place. The monomer contained in the acrylic mass dissolves the surface of artificial teeth and bonds them with the polymerizing acrylic. There is no monomer in thermoplastic dentures, so there is no need to dissolve the teeth. In order to connect acrylic teeth with thermoplastic, a mechanical connection must be made. The strength of the bond between the tooth and the denture plate and the aesthetics of your work will depend on the quality of this preparation. A well-prepared tooth is integrated with the plate of the thermoplastic denture as tightly as it is with the plate of the acrylate denture. The strength of the fixation is ensured by a mechanical joint, that is, a step on the perimeter of the tooth, and T-shaped holes. However, errors in the technique at the stage of tooth preparation may weaken this connection. The most common mistakes are lack of mounting holes, incorrectly made holes, holes drilled over the reach of the denture plate, lack of undercut around the tooth, grooved instead of undercut, incorrectly shaped undercut. As you can see, there are quite a lot of possible mistakes during tooth preparation. Let's start with the holes. It is absolutely unacceptable to embed teeth in thermoplastic dentures without making T-shaped holes. Some technicians only make recesses with a ball drill instead of holes. The hole carved in the tooth adds nothing and does not integrate it with the denture plate. Such teeth often fall out shortly after the injection. This was the case with the situation presented on the screen. When asked what to do next, whether the work would be repeated, the technician was sincerely surprised and said, "Why? Everything is okay. I will paste my teeth with acrylic and take it to the practice. I've been doing this for years." Just horror. The correct preparation of the tooth for injection technology consists in making 3 holes with a drill with a diameter of about 1 to 2 millimeters. 1 hole underneath, 2 on the sides of the tooth, important, under the edge of the undercut. The holes must connect with each other. During injection, the molten material flows inside the tooth, fills the holes and permanently bonds it to the denture plate. How can you spoil it? It would seem like a simple activity, however this shows that you can. It is a mistake to make only the lower hole. The hole made in the tooth axis will not provide adequate retention. These are simple laws of physics. It is a mistake to make only side holes because it is the bottom hole that transports the largest mass of plastic. Besides, it may happen that for some reason the material will not flow to the side opening from the outside, but it may flow through the bottom channel, fill the space and save the situation. It is a mistake to make a hole above the reach of the denture plate. It is logical that if the hole is above the injected material, the material may not flow there. Transport of the material through the bottom channel may be insufficient. The biological remnants will get into such a hole, not filled with plastic, and the unpleasant putrefying process known to all will begin. The holy rule: the holes must be under the edge of the tooth undercut and under the line of reach of the denture material. You should strive to create the maximum strength of the connection of the tooth with the denture plate. Therefore, in addition to drilling holes, undercut the edge of the tooth along its perimeter should be performed. The undercut has 3 very important functions. First, it increases the retention of the tooth with the plate. Secondly, it seals the boundary of the contact between the tooth and the plate. Thirdly, it improves the aesthetics of the prosthesis. The retention function is ensured by an appropriate trapezoidal shape of the undercut, which is made with an inverted cone cutter. The trapezoidal shape, narrower at the top and wider at the bottom, increases the fixation of the tooth in the denture plate. It is a mistake to make an undercut with straight walls. Such a step will not fulfill the retention function. However, the most important function of the undercut is the circumferential sealing of the border between the tooth and the denture plate. Of course, we remember that the acrylic tooth does not chemically bond with the thermoplastic. Therefore, if we do not make an undercut on the tooth, a pocket will form between the surface of the tooth and the denture plate, which biological debris will be forced into while chewing food. The result of the action of the bacteria will be a bruising of the pocket and an unpleasant smell. A properly made undercut eliminates this problem, effectively seals the connection between the tooth and the denture plate and prevents food debris from settling. The prerequisite is the preparation depth, which ensures the appropriate stiffness of the material is at least 1 millimeter. But this is the minimum. If possible, make an undercut up to 2 millimeters deep. The second condition is to model the denture plate exactly to the edge of the tooth preparation. The most common mistakes are, of course, no undercut and modeling of the plate above the edge of the tooth preparation. In both cases, a pocket will be created. The last function of the undercut is to improve the aesthetic effects. Thermoplastic materials are more transparent than acrylic, so if we do not skillfully cut the tooth neck, it will be visible and the aesthetics of the prosthesis with such teeth will not be satisfactory. In order to hide the neck, the undercut must have the appropriate thickness, that is, 1 to 2 millimeters, and the correct shape. It is a mistake to make a groove instead of an undercut. The seal of the tooth with the plate is weaker and the neck is clearly visible. It is a mistake to make a groove instead of an undercut. The seal of the tooth with the plate is weaker and the neck is clearly visible. At this point, I would like to point out the attention to the appropriate length of the tooth. In traditional technology, during flasking, the teeth are put on acrylic, so the distance between the tooth and the model does not matter. In the injection technique, the distance between the tooth shaft and the gypsum model should be large enough to ensure a free flow of the injected material from the side of the channel to the buccal labial part. The minimum space is 1.5 millimeters in general. The more the better. Therefore, it is a mistake to leave too little space under the tooth, as a result of which the prosthesis does not inject from the vestibule. Most often the clamps are not injected. Technicians then use some strange methods, such as additional channels supplying the atrium clamps, which may be effective to some extent, but unnecessary. It is enough to cut the uninjected denture and check if there is enough space under the tooth. It is not always advisable to have a large amount of space between the tooth and the model. Well, in the case of a strong disappearance of the ridge, there is a situation where the patient's atrophy of the ridge has to be supplemented with material. First, it is a large waste of material, and we must remember that we are limited by the capacity of the cartridge. Secondly, a technologically unfavorable system is created. A thin palatal plate passes into a thick space under the teeth and then into a thin vestibular plate. The phenomenon of the formation of a shrinkage cavity known from metal casting may then arise. As it solidifies, the thin parts of the plate will cool down faster and will treat the mass of material under the teeth as a reservoir to compensate for its contraction. As a result, a contraction cavity will appear at the thickest point of the denture. When modeling a denture with a strong atrophy of the process, it is worth leaving a sufficiently long tooth shaft. It will fill the space, reducing material waste and the risk of shrinkage formation. Tooth preparation is a very simple activity, but paradoxically, it is often performed incorrectly. Unfortunately, I rarely see dentures with properly prepared teeth. I have the impression that technicians underestimate the role of tooth preparation, while the impact of properly prepared teeth on the quality of the denture is important. Therefore, an absolute requirement is to relieve the arm of the clamps and, what is also important, all places susceptible to possible irritation, such as anatomical warts, furrows, nodules and the vicinity of the gingival pockets of all the patient's teeth in contact with the prosthesis plate. We create the relief with wax on the primary model and duplicate the prepared model with plaster and only then continue modeling the prosthesis. The proper practice is to return the prosthesis to the office on the original model, as it is the case with skeletal prostheses. Firstly, it confirms that we have performed the steps of relieving and duplicating, and secondly, it gives the dentist the opportunity to perform a preliminary assessment of the prosthesis and possible corrections.
Multipress is a machine that allows for effective injection of dentures from any material, and the full automation of the process facilitates the work of technicians with less experience. If you want to know more, visit rokodent.com.
Failure to make relief and duplicate the model will completely disqualify the prosthesis. Such behavior should be absolutely stigmatized because such pseudoprostheses, instead of improving the patient's comfort of life by rebuilding the occlusal system, irreversibly destroy it. Unfortunately, each buckle of a settling denture, whether it is a wire acrylic denture or made of plastic, of a nylon denture, will hurt the gingival pocket while it settles. Such a beauty of a settling denture. On the other hand, a denture made of a rigid material such as, for example, Acron, can be equipped with supports and will not settle down as well as a metal skeletal denture will not settle, and the effect of its clamps on the periodontium will be neutral. Unless the technician did not want to relieve and duplicate the model. Unfortunately, I regret to say that this is still a common practice. Has it ever happened to you that after an injection, when removing a plastered denture or during processing, the denture literally fell into two pieces in your hands? The situation described can occur with technicians who use film-forming insulators to insulate plaster or water glass with the wrong density, and the injection system consists of two or more channels. The genesis of such a situation is as follows. The molten material is pressed into the flask and, filling the mold, rubs against the plaster surface. If the insulator forms a layer on the plaster surface that is not permanently bound to it, then the material flowing into the flask may scoop up a part of the insulator and press it in front of itself. As the material flows through two channels, at the meeting point, the scraped insulator creates a barrier that prevents the material from creating uniform form. A characteristic feature of this defect is a thin and even line across the denture. This defect is problematic because it does not always show up at the laboratory stage, and there is a risk of the prosthesis breaking after it has been handed over to the patient. It is also difficult to unequivocally diagnose at what stage of the isolation it was created, whether as a result of inadequate insulation density, too wet or maybe too dry model, plaster quality and so on, which makes it likely to happen often or hardly ever. The only solution is to abandon film-forming insulators in favor of UV curable isolators such as Luvots, which create a hard abrasion-resistant surface on the plaster. In the event of a broken denture, you should carefully examine the edges of the crack, for example with a magnifying glass. If, after separation, you can see that the edges are smooth and one edge is concave and the other is convex, the breakage is the result of pressing the insulator. One of the most difficult defects to diagnose are the pores in the denture plate. Pores are formed as a result of shrinkage, overheating, insufficient amount of material, and moisture. The contraction pores are the result of uneven contraction of the molten plastic mass and are located in the denture plate next to the infusion channel or under the teeth. I have discussed the detailed analysis of the formation of pores under the teeth and the methods of how to avoid them. On the other hand, the pores located next to or at the junction of the channel and the prosthesis plate are the result of narrowing of the channel at the point where it adheres to the denture plate. While cooling down and shrinking, the plate should replenish the material from the channel and the remains in the cartridge. If the channel is cut through, then in the thinnest point it cools down faster than the thick mass of the plate and blocks the lumen of the channel, making it impossible to replenish the mass of the material. This is a known problem in casting steel bridges or skeletals. Remember that in the thermoplastic technique, as in the foundry, the principle of thick into thin works. If you have such a pore in the prosthesis, carefully inspect the place where the channel meets the prosthesis plate. If it is narrower than the entire channel, you have found the reason. Pores can also arise from the cartridge becoming stuck in the sleeve. I mentioned the causes of this phenomenon earlier. Now I will discuss the effects. Due to partial blockage of the cartridge, the material gets into the mold but does not fill it under the appropriate pressure, which causes characteristic pores. The material looks like it is boiling. Technicians often find that the cause is too high a temperature, which is obviously a mistake. They start to tinker with the temperature change. They try to calibrate the injection molding machine, which results in chaos and total problems with the injection. And it was enough to use the right lubricant, for example, and it would be over. The last type are pores formed as a result of moisture in the material. Most modern thermoplastic materials have minimal absorbency, but the laws of physics cannot be deceived and, unfortunately, condensation cannot be eliminated. Perhaps some of you have come across a recommendation not to turn on electrical appliances immediately after bringing them from a cold room to a warm one. This recommendation is caused by the phenomenon of moisture condensation, which may appear on the electronics board and may cause a short circuit and failure. The same phenomenon of condensation takes place during the heating of the material. Moisture settles not inside but on the surface of the granules and turns into water vapor during rapid heating at 100 degrees Celsius. Remember that the material is heated up to 300 degrees Celsius and the steam creates enormous pressure. In the event of moisture, the cartridge may open, causing the buildup of vapor to expand. However, sometimes it can withstand the pressure of the vapor and it seeps into the prosthesis, causing pores in it. The technicians who self-pour the granules into the cartridge are most likely to experience bursting of the cartridges and forming of pores. In the conditions of a prosthetic laboratory, it is not possible to ensure 100% tightness of an open package with granules. The only solution is to use factory-dried and sealed and hermetic cartridges. When flasking traditional acrylic dentures, lifting of the bite often occurs, which is the result of squeezing the acrylic dough between the two halves of the flask. In injection technology, the phenomenon of lifting in the bite should not occur because the material is pressed into a previously closed mold and the prosthesis cannot be physically deformed. However, such cases do happen. Why? There are several reasons, but all of them result from improper handling of the flask. First, clean the contact surfaces of the aluminum flask halves. If, before injection, a lump of plaster or other contamination gets between the flask halves, they will not stick to each other perfectly and the injected prosthesis will be higher by the thickness of the contamination. The same situation will occur if the lump gets between the model and the counter. When using plaster, we assume that you are using professional plaster for injection technology, and not Jutani that you have. If the plaster is not resistant to high temperatures and is too soft, then due to the pressure of the material on its surface, it may also deform and raise the bite. Raising the bite may also be the result of improper screwing of the vessel, and during injection, the halves of the flask may slide apart. The problem is not caused by a low torsional force, but by contamination of the threads, most often by wax and plaster. As a result, the technician feels that the flask is well screwed because it feels a strong resistance when tightening, but in fact it is not. Resistance is a result of dirt blocking the screw thread. You should take care of the cleanliness of your work tools, also flasks. The final reason that the bite may be elevated is that the flask has been mechanically damaged by the technician. Unfortunately, most of the technicians have bad habits in making acrylic dentures, and they furiously bang the can with a hammer to knock out the plaster denture. This is a drama. The Flask is made with the precision of the order of hundredths of a millimeter because it must ensure the repeatability of the mold adjustment. If you hit it with a hammer, it will deform irreversibly and your dentures will never be perfect again.
Acron is a new polymer which is used in order to make perfect dentures. 10 years of clinical experience and millions of satisfied patients in 30 countries is the best recommendation. If you want to know more, visit rokodent.com.
Remember, never hit the surface of the flask. Before pouring the plaster, it is enough to coat the inside of the flask with a thin layer of the Isoflex type insulator. After injection, you can easily release the plaster by gently striking the hole. If you work on broken and deformed flasks and you want your dentures to be fit and precise, absolutely replace the flask with new ones and do not destroy them anymore. The injection technique is simple, requires only one: compliance with the rules. Do not make your life difficult by approaching work in a style and why I will drill 3 holes in the tooth, I will do 2, or why some milling of the undercut in the tooth, I will make a groove with a rose, and it will also be beautiful. Well, no, it won't, but sooner or later you won't succeed and you will lose a lot of time. All the problems I have discussed are the result of the creativity of some technicians, diligently looking for shortcuts, skipping unimportant, in their opinion, stages of work, finding apparent savings and substitute materials. They can be avoided in a simple way. Work according to the manufacturer's recommendations, in accordance with the principles of professional art, and use appropriate auxiliary materials. Then your prostheses will be perfect. Thank you for your attention and invite you to watch videos on the Tech Dental TV channel. If you like the movie, give us a thumbs up and subscribe. See you next time.